Hello everyone and welcome back to this next lecture. So in the previous lecture we talked about hardware skills acquired as a power electronics engineer. Now in this lecture I'm going to talk about simulations. Before we implement any concept in hardware, the recommended method before that is to perform a simulation study. Right? Now long back, before simulation softwares were available, people would directly jump to hardware from simple paper analysis. So you would analyze the system on paper using pencil paper and you would directly migrate to a hardware setup. Now that simulation software are much more readily available, a simulation study is quite normal nowadays. The reason is a simulation allows you to examine in detail every aspect of a circuit's operation. Right? You can observe all the currents and the voltages in every part of the circuit, even those intermediate parts which normally you would not analyze. This is the advantage of a simulation study. So if you feel that the current in any part of the circuit is increasing too much, you might want to look into it again, or you might want to find ways to suppress that current or at least limit it to some extent. So this is the advantage of a simulation study. Now in most cases, simulations are performed using specialized software, usually. Nothing stops you from writing all the equations on your own and programming it to simulate it. But usually you don't do that anymore, right? It was necessary a long time back when there were very few simulation software and those were very expensive. So therefore, it was normal to actually write programs in MATLAB or C or C++ and solve and actually execute them. But nowadays, it's usually not necessary because many specialized software are now available. Right. So for example, as I already said, there are many simulation software and it is very difficult to actually pick one out as the best. Right. Each and every one of them has something special about it. And on the contrary, the reason why each and every one simulation software was developed was that the founder wanted to emphasize on a particular aspect of simulation that he or she felt was neglected. So therefore, almost every one of them has something special. So over the course of my time in academia and industry, I have used many simulation software. I've used MATLAB, I've used PSCAD, I have used PSIM, I have used Plex, and a few also smaller softwares which I've maybe used to evaluate whether they were worth using for our projects. Now I am the creator of the free and open source circuit simulator Python Power Electronics. Right? And this I use for teaching power electronics online. So I don't use proprietary circuit simulators anymore. I have my own free and open source circuit simulator, and I specifically emphasize on using open source software for engineering purposes so that students and engineers in every part of the world, including developing countries, can use software without being curtailed by expensive licensing fees. That is now what I try to do. I promote free and open source software, including my circuit simulator. So simulation studies are done for various reasons and they are in various forms. Right? So as we already said, one potential simulation study that can be done is just before a hardware implementation. So this is just to verify that nothing is going wrong, you're not going to blow up the circuit, currents are not going out of the limit, things like that, right? It is just to ensure that the hardware has no hidden surprises. However, you can expand the scope of a simulation study to cover some more complex parts of the system which might not be that difficult to study, right? For example, you might want to simulate in specific detail the behavior of a machine under special circumstances. So for example, if you're simulating an induction motor, you might want to also simulate what happens when the induction motor develops a fault. Now, in hardware, you would actually have to create a fault in your motor, which you may not want to do because you'll be damaging your machine. But in a simulation, that's not a problem. So these kind of simulation studies expand the scope of your knowledge, which you probably might not want to do right away in a hardware implementation. Now, simulations are also very useful in studying very large systems like smart grids. right? So these are interconnected systems with many converters, many blocks, and such systems may be very difficult to implement in hardware, right? Because if you have, let's say for example, you want to study the effect of a wind farm with 20 wind turbines, it is incredibly difficult to actually implement something like that in hardware in a laboratory. It is very difficult, right? So therefore, in such circumstances, simulations are quite useful, because now you can simulate the behavior of the wind farm and examine the impact of the wind farm on the power grid and vice versa. You can also study the impact of the power grid on the wind farm. So these kind of simulation studies are useful when hardware implementation might not be very convenient, at least not right away. Maybe at a later stage you might want to gradually build to it, but not right away. Now it's important to note that simulating such large systems is very complicated, and that is a very valuable skill, right? Nowadays, simulating specific converters or simple circuits that are going to be implemented in hardware is quite easy. So simulating only for hardware implementation is not such a valuable skill, because many simulation software are available. But simulating large systems still remains a very valuable skill, because now you need to put all these different blocks together. So this is something that many companies still look for. So it's important to note that there are many simulation software. As I already said, I myself have used at least 4, and there are probably dozens of them available online. So you might be wondering, like, which should I use? What do I do? But it's important to note that almost of them have their similarities. So it's not like if you simulate using one system, you would never be able to simulate using another system. So if you are well versed or even an expert in any one of them, you can pick up another simulation software without too much of a trouble when you join a company or a university. So for example, if you are used to simulating in MATLAB in university, and if you join a company and you find the company uses Plex, you won't have a tough time migrating from MATLAB to Plex, right? Because the simulation concept is not very difficult, right? And nowadays, many simulation software allow interoperability. For example, many simulation software do say you can integrate with something else. So if you write code in MATLAB, another simulation software say we can execute this code directly. So these kind of things are also happening. So therefore, do not worry about not being able to use a particular simulation software. If you are an expert in one, you can very quickly pick up another if you do have to use it under any circumstances. So if you are a student, right, if you are an undergraduate or anything else, check out if there are any simulation softwares available in your university. Many universities maintain licenses, and these are academic licenses for simulation software. For example, many universities maintain MATLAB licenses, they maintain PSCAD licenses, they maintain many other licenses. So it is always possible. So check out which simulation softwares are available in your university, right? If there are any softwares, try to use them and try to get comfortable with them. If, however, you do not have any access to licensed software, if you are in a university that does not maintain any licenses, or you are not in a university and therefore you do not have such access, in that case, check out online for some other free simulation softwares. There are many simulation softwares available free of cost. As I said, I myself am the creator of a circuit simulator which is free and open source. You can use that, which is called Python Power Electronics. Otherwise, you can use many others which have also been released as free and open source. If not open source, at least they are free. So go ahead and try out some of these. As I said, do not get too worked up about not being able to use one particular software. If you can use any one software and get comfortable with it, you can always migrate to any other software. What's important is you understand the concept of simulations. That is what is important. So with this, I will end this lecture. This lecture was to give you a glimpse of another skill which is actually very useful as a power electronics engineer and which can also find you a job. So If you have any doubts, please do post. Otherwise, I will see you in the next lecture. Thank you so much and see you soon. Goodbye for now.